All right, Geometry Crew. Today we're going to go over day 8 of our pre-SAT unit, and this is just going to talk about rules of exponents, going over many different examples, talking about exponents because that's always something that appears on the SAT, and it's always something that's very good to practice. So we're going to go over different examples, rule by rule, demonstrating the rules of exponents. Right? Some of these are going to be a little bit quicker. Some of them are going to take a little bit longer to complete. Also, when we're talking about simplifying expressions using the rules of exponents, there's so many different ways we can do some of these problems. Okay, we could apply different properties in different orders. So just keep in mind there's flexibility here in terms of what we can do to simplify these expressions. All right, so rule number 1 that we're going to go over is the negative exponent rule. So the negative exponent rule just states, like, move the negative exponent of the opposite part of the fraction to make it positive. So to change this exponent from, to get rid of that negative exponent, all we have to do is put this on the other side of the fraction bar. All right, so if it's in the numerator, we put it in the denominator. If it's in the denominator, we can put it in the numerator. All right, that's just because when we raise something to a negative power, that's basically like dividing it. Okay, so instead of like 1 times a to the negative mth, okay, we could divide by a to the mth power. Okay, so if we take a look at the first example, x to the negative third power, we're just going to put that on the other side of the fraction bar. So what we're left with in the numerator there is 1. All right, this is just 1 times x to the negative third, so we have 1 over x to the third. All right, in this next example, the first thing that I'm going to do is just get rid of those negative exponents. To be a simplified expression, we want to get rid of those negative exponents. So in order to do that, I'm going to take that, put it in the denominator, take this a to the negative fourth, put it in the numerator, and that'll change those signs. Okay, that's the first thing that we could do. So we're going to have x in the numerator, and a to the fourth is going to be in the numerator now. And then we got 5. All right, b to the third is still in the denominator, and then y to the third is going to be in the denominator. All right, if we take a look at this next example, notice we have 3 times x to the negative third in the denominator here. Now, the operation that's happening between the 3 and the x to the negative third is multiplication. So that 3 is not really bundled into this x to the negative third. So we're not raising 3 to the negative third power, just x. So it's important that that 3 stays in the denominator. So we'll have x cubed in the numerator and then 3 left over in the denominator. If it was the intention that that 3 was also being raised to the negative third, you'd see that like shown. You'd see that whole quantity raised to the negative third. But obviously that's not what we see. So that 3 stays in the denominator there. All right, now we have 3 to the negative second times 2 to the third. All right, so this one's negative, so that's going to go in the denominator. So we have 2 to the third over 3 to the second. And in this case, we could actually evaluate what these things are. 2 to the third is just 2 times 2 times 2, or 8. 3 squared, 3 times 3, or 9. All right, so that's applying the negative exponent rule. To get rid of that negative exponent, you just put it on the other side of the fraction bar. Simple as that. All right, power of 0. Anything to the power of 0 equals 1. So if we say anything raised to the 0th power, that's 1. So there's our example there. That's just demonstrating the rule. So obviously y to the 0th, that's just 1. All right, this whole quantity, doesn't matter what it is. It could be a billion raised to the 0th power. It's still just going to be 1. All right, 2 to the 0th, that's 1. We got to be careful in the denominator here because not everything is to the 0th power. It's just the x. So we still have that 5 squared. So we have to actually evaluate 5 squared. So we get 1/25. All right, then right here we also have to be careful. Remember, if it's intending that whole thing being raised to the 0th power, then we would see parentheses. We don't see parentheses around the 3. So this is 3 times x to the 0th power, which is 1, plus 5 times y to the 0th power, which is 1. So that's just saying 3 plus 5, or 8. And then finally, there's where we see this whole quantity being raised to the 0th power, so that would be 1. So the 0 power rule, pretty easy to deal with. All right, so moving down, adding and subtracting exponents. All right, this is not necessarily a rule of exponents. This is just basic rule of like terms. In order to add or subtract exponents, we got to have the same base raised to the same power. That's just how we combine like terms. All right, when we combine like 2x plus 3x, whoops, 3x, we get 5x, right? And the reason why we can do that is the base is both the same and the power is both the same. All right, so we don't think about that when we combine it, but this is true. All right, so if we take a look at this example, 3x squared plus 5x squared, it's got to have the same base raised to the same exponent. All right, so 3x squared plus 5x squared is going to be 8x squared because they have the same base raised to the same exponent. If we take a look at this next example, one of the bases is x, the other base is y. So these are not like terms, therefore we can't combine them. So that is already in simplest form. Same with this third one. All right, this, although it's not written there, it's implied that this is raised to the first power. All right, so we have x to the first power plus x to the second power. The powers aren't the same. They're not like terms. And then finally, we have x squared minus 5x squared. Remember, this is a 1x squared. Also implied here is the coefficient, which is 1. So 1 minus 5 would be negative 4. So we have negative 4x squared. That has the same base raised to the same power. Awesome. All right, moving on. The next rule that we have to talk about is multiplying exponents. So all of these rules, if you remember correctly in Algebra 1, we demonstrated why these things were true. Okay, before we did anything, before we just gave you the rules, we showed you that, hey, we could come up with these rules on our own. So just to show that example, let's say we're talking about 2 squared times 2 to the third power. All right, we know what 2 squared is. That's 2 times 2. And we know what 2 to the third power is. That's just 2 times 2 times 2. Okay, so if we would rewrite this, this is just multiplying 2 5 times. So that's 2 to the 5th power. Now we can see what we're doing there. Okay, to get this new expression, we're just adding those exponents there. So as long as the base is the same, we can just add the exponents, and this is called the product rule. Product because these two powers are multiplying by each other. All right, so we have x squared times x to the 5th. As long as the base is the same, we can use this rule. So if we add those exponents, we have x to the 7th. All right, and remember, once again, the reason why is, hey, x squared is just x times x. X to the 5th is x times x times x times x times x. So really, we're just multiplying x 7 times. All right, so we can condense that expression. All right, if we take a look at the next one, remember, right here, okay, 3 is not being raised to the 7th power. It's just a normal 3. We got 3 times x to the 7th times 7 times x to the 4th. 3 times 7 we can actually do. That's 21. All right, 7 also isn't being raised to the 4th power there. All right, so we can do that regular multiplication. Now, when we have x to the 7th times x to the 4th, it's got the same base, so we can add those exponents. So we get 21x to the 11th power. All right, this one, base isn't the same. All right, so we can just rewrite it if we so choose as a cubed b squared. All right, it's implied that this is multiplying there. We don't need that dot. All right, and the next one, All right, multiple things going on. We got the coefficients that we could multiply. 2 times 5 is 10. And then both of these have x's. This is raised to the first, that's raised to the first. So x times x would just be x squared. And then right here, y to the 2/3 times y to the 1/3. Well, 2/3 plus 1/3 is just 3/3, or 1. So that's just y to the first. So we have 10x squared y. All right, moving on to dividing expressions. All right, this is where it can get a little tricky. All right, in these examples here, we have a lot going on, and there's many different ways that we could do these problems. Remember, we've got all these rules at our disposal that we used before. Okay, so we've got like the zero power rule. We've got the negative exponent rule. Okay, obviously now we have the product rule. When we're dividing exponents, this is using the quotient rule. And what it's saying is, okay, to simplify this expression here, all we have to do is subtract. So we could take this quantity on the top, subtract that exponent on the bottom. So as long as it has the same base, we keep that base the same and then just subtract their exponents. And we always start on the top there when we're subtracting their exponents. All right, so we're going to see this helps us in some cases. In some cases, we're going to see that we have to do like one more additional step after that. So in this example, we have x to the third divided by x squared. That could be rewritten this way. All right, and we're going to keep the base the same and subtract the exponent. So 3 minus 2 gives us 1. Once again, remember why this is happening. X to the third is just x times x times x. X squared is just x times x. Anything divided by itself is 1. So these two cancel out, and we just have 1 left over. All right, that's a really important concept when we get to big expressions with a lot of exponents. All right, I'm going to rewrite this next one as well. So 25x to the 7th divided by 5x to the 3rd. All right, 25 divided by 5 is 5, first of all. That would be a 5 in the numerator. It's just a regular old 5. All right, and then we have x to the 7th divided by x to the 3rd. We keep the base the same, and then we subtract those exponents. 7 minus 3 is 4. All right, if we take a look at the next one. So let's just straightforward use the quotient rule to start. And then we could think about, oh, how could we do this a little bit more efficiently in the future? Okay, so first we have x to the 2/3 over x cubed. All right, that's something that we could simplify. All right, so if we subtract, all right, 2/3 minus 3, okay, 2/5. My apologies. 2/5 minus 3. 3 is 15/5. So we have 2 minus 15, which would be negative 13. So we have x to the negative 13/5. All right, and then we have negative 3 minus 1 in terms of our y's. Negative 3 minus 1 is negative 4. And then that's a 1 also. So z to the 1st over z to the 7th. 1 minus 7 is negative 6. Man, all these are negative. All right, so what we could do is just put them in the denominator. All right, we got to put each one of these on the other side of the fraction bar. All right, so it's going to be 1 because there's nothing left over remaining in the numerator except that coefficient of 1. And we have x to the 13/5, y to the 4th, z to the 6th. All right. All right, cool beans. Let's move on to the last one of this type. All right, so now we have negative 12 divided by 4, which is negative 3. All right, we can just do our regular operation with the coefficients there. Now we have a to the 5th over a to the 1st. 5 minus 1 is 4, so that's a to the 4th. And then right here, for our b's, to simplify that, we've got negative 3 minus negative 5, which would be positive 2. So that would be simplified. All right, folks. Last set of rules here is our power of a power rule. Right? In the power of a power rule, we're taking one power to another power. Right? So when we're taking one power to another power, let me get my pen tool back. There we go. Let's use this as an example. 2 cubed raised to the second power. Okay, what this means is we're squaring this quantity. Whatever this is, we're going to square that thing, which means multiply it twice. So that's just 2 to the third times 2 to the third. And remember what 2 to the third is. That's just 2 times 2 times 2. And then the other 2 to the third is also 2 times 2 times 2. If we count up how many times we're multiplying by 2, that's 6 times. So we can see the operation between these exponents that we're doing here is multiplying. All right, so when we have a power to a power, we're going to keep the base the same and multiply those exponents. Now this one is a different scenario. Let's say we had multiple things in that that are being raised to another power. We would just apply that power to each one of these factors. And when I say that, I mean A is a factor, B is a factor. Let's apply that power to both of these factors. So we would have A to the mth times B to the mth. So in this first example, we're going to apply this power to each one of these factors. And as we do so, we're going to use this power rule. Okay, so we're going to multiply those exponents. So 3 times 2 is 6. 5 times 2 is 10. Pretty simple. Simple as that. All right, the same thing is true when we're dealing with a fraction. Okay, we need to apply that power to all of these factors, everything in the numerator, each factor in the numerator, and each factor in the denominator. So we're going to apply that power to the 2, to the x to the 5th. Now, as we do this, so that it's not too many steps, and I'm not dragging it along too long, I'm going to use that power rule. So x to the 5th raised to the third power is just x to the 15th. And we have 3 cubed, and then x to the negative third raised to the third power is x to the negative 9th. All right, and we still got some simplification to do. Notice that in the numerator and denominator, we have 2 powers that have the same base, so we need to simplify that. We could do that multiple ways. We could bring that up top using the negative exponent rule, and then use the addition rule there. Or what we can do is just subtract. So 15 minus a negative 9, that would be x to the 24th. And then, of course, we could evaluate 2 to the third is 8, 3 to the third is 27. All right, let's check out this one. We're applying a negative exponent to each one of these factors. To start out, as we do that, I'm going to use that power rule. So x squared raised to the negative 1/2. That's going to be 2 times negative 1/2, which is negative 1. All right, for y, we have negative 2 times negative 1/2, which is going to be positive 1. Now we need to get rid of those negative exponents, so we're going to put them on the other side of the fraction bar. So we're going to have y over 3 to the 1/2 times x. Okay, I'm not a fan of that 3 to the 1/2 there, so I'm going to simplify that even further. When we raise something to the 1/2 power, okay, hopefully you remember that it's like taking the square root. Right, so when we simplify, we can have y over x times the square root of 3. All right. And the last one, let's apply that power to each one of these. Now, once again, we could do this many different ways. You could always start by simplifying what's inside if you can, and then apply the power. That's a really good technique, of course, or you could just apply the power rule to each one. I'm just going to utilize that power rule, so I'm just going to apply it to each one. It's not the most efficient thing. So we're going to have 2 to the 4th times x to the 12th times y to the negative 20th divided by 4 to the 4th, also x to the 8th and y to the 4th. All right, we're going to simplify what we can. All right, so first thing I see is that negative exponent. I could bring it down alongside this y to the 4th, and that would become y to the 24th in the denominator. And then for our x's, we could subtract, and we get x to the 4th in the numerator. All right, but we're not done yet. We've also got to deal with these two things, 2 to the 4th and 4 to the 4th. 2 to the 4th is 16. 4 to the 4th is 256. So if we simplify that fraction, we get 1/16. So this will be x to the 4th over 16y to the 24th. All right, folks, that's using a lot of the properties, many different types of examples, and I think you'll have a good scope of how we could use our exponent rules for SAT-style questions after this. All right, if you have questions, please let me know. Send me an email, message me. Thanks. Have a good day.